Geometry students, and welcome to combined 323 and 324 lesson. 323 is still talking about triangle similarity and then adding in the idea of congruence, but it's a fairly short lesson. And then 324, we're going to look to see if there's any other shortcuts besides the ones we've already found in 321. Notice we did skip 322, so we'll talk about that though in this lesson, what I want you to do from there. So notice, by examining and testing side ratios and angles, you are now able to determine whether two figures are similar. But how can you tell if two shapes are the same shape and the same size, okay, which is what congruence is? And you're going to look at properties that guarantee shapes are exact replicas of each other. Okay? Note that some figures in this lesson and throughout the course may not be drawn to scale. You always use factual information stated about or marked on the figures to make decisions. So again, don't go off of looks, go off of mathematical facts is basically what they're saying, and we've talked about that before. In problem 371, notice they want you to figure out whether these triangles below are similar or not, and then notice right here it says to use a flowchart. Come on. Notice it says to use a flowchart to organize your facts and conclusions. Anytime you see that going forward, whether that's in a lesson or whether that's in a for now, that's in your practice to learn, I want you to just put an explanation along with your answer, okay? So for example, in part A, if you notice, we're looking at these two. First thing, remember, what we're looking for in this case is either angle-angle similarity or side-angle-side similarity, okay? Well, if you notice in this one, right here, we have one set of congruent angles, and here we have a second set of congruent angles. Therefore, I know that those two triangles are similar because of angle-angle similarity. Okay? And if I wanted to, I could go through now and I could write a similarity statement. Let's say that I put down triangle ABC is similar to triangle, and at this point, you got to match stuff up. So angle A was the one that had one dash on there. Angle D would correspond with that in the other triangle. Angle B had the two dashes, that would go with angle E. And then finally F would match up with angle C. So those two triangles are similar because of angle-angle similarity, and this would be the similarity statement that would go along with it. Okay? If we take a look at part B, so notice, first off, they give you some side lengths. Notice they do both have a 90-degree angle. Okay? But that's the only angle we know. So the only other thing we are going to check then is side angle side similarity. Meaning, I need to check those two sides, and I need to check these two sides, okay, to see if we have the same ratios. So as we go through and we try to match things up, the 12 from the first triangle is going to match up with, okay, that's the shortest side length, therefore it's got to match up with the 9 from the second triangle. Okay, and the 16 and the 12 will go together. So those are the ratios I need to check. So if I go through and we take 12 divided by 9, okay, 12 divided by 9, that ratio is 1.3 repeating. Okay, then if I go through and I take the second set of ratios, 16 divided by 12, if I do 16 divided by 12, that is also 1.3 repeating, and therefore these two triangles are similar by side-angle-side similarity. They've got two sets of equal ratios, and the angle in between is congruent. They're both 90 degrees. So these triangles have to be similar to each other. Once again, if I was going to write a similarity statement, let's say I write triangle IHG similar to triangle, and now we got to match things up. Since I is in the first one, notice that's between the longer leg and the hypotenuse. That means here's your longer leg, here's your hypotenuse. That means that's got to go with angle J. H is the right angle, therefore matches up with L, the right angle, and the only one left would be K. So there would be your similarity statement for that one. In part C, in this case, what you can notice is I don't know anything about the angle, so that means angle-angle similarity is out. I also don't know anything about I can't use side angle side either because I don't have a set of congruent angles. So in this case, I don't know for sure whether these are going to match up. What we could do is we could check the sides to see if they're in the same ratio. And so if you notice, the smallest side from the top one would match up with the smallest side from the bottom one. So if you notice, that's half. Then if we match up, the next biggest one would go with the next biggest one. That is not half. And then if we go to our last part, 14 and 7 would match up. That is half. Notice these side lengths are not all in the same ratio. Therefore, these two triangles are not similar to each other. And then our last part, part D, we're taking a look to try to figure out if these are similar triangles. And so notice they give you a bunch of different measurements, okay? And they give you a set of congruent angles. We kind of talked about this one in the last lesson, that if those angles are congruent, that means these lines have to be parallel, which then would also mean that those angles have to be congruent because those are also corresponding angles. The other option is you know that angle M in this shape is congruent to itself because it's the same angle in both triangles. So once again, we know that these two are going to be similar by angle-angle similarity. Okay, that's our justification. And therefore, let's say I wanted to write a similarity statement. I would put in here, I'm going to use the small triangle MNS. Would have to be similar to triangle. We said M matched up with itself, so I can put that first. Angle N matches up with angle T. And then the last part is V. There would be your similarity statement stating that the smaller triangle is similar to the bigger triangle. All right, so there's that part of it. Then the next part just asks you to go through and see if you can find some missing side lengths, okay, in this case. So if we go through and we take a look, the first one, if you notice, they want you to find length BC. I'm just going to put an X there, okay? Then they want you to find length AC, which we could go through and we could see if we can do that. In this case, BC would match up, this side length that I'm looking for would match up with the 38 from this side. I know that because it's the side length that's between the angle that has 2 markings and the angle that has none. There's your 2 markings, there's your none, there's the side in between. So those two go together. And then the other part, the 12 from this first triangle would match up with the 42 from the second triangle. Okay? And again, I know that because that side length is between the angles that have markings, and so is the 42. So now I can go through and set up my equal ratios. So let's say I go with X over 38 equal to 12, since I started with X in the first one, over 42. And now we go through and cross multiply. I get 42 times X. That has to equal then 38 times 12, which is 456. And now I solve for X, and we end up with approximately 10.86 if I round to the nearest hundredths place. And that's what I want you to do if you're going to round a side length. Go to the hundredths place. It turns out, here's a quick rounding lesson, turns out that this answer is actually 10.857, and it keeps going. If I'm going to round to the hundredths place, remember you always take a look at the number next to that. If it's 5 or greater, you round up. If it's less than 5, you just drop it off and keep the number. Okay, so just a heads up on that one. Then, in part B here, they ask you to find AC. So let's say that I put like a Y right there. And unfortunately, we're not going to be able to find the length of AC because I don't have a corresponding side to go with it in order to set up a ratio and use a zoom factor. And so since I don't have that, unfortunately, we cannot find it. Okay? Then if we come to part D here, well, C and D, they are asking you to find, in part C, I'm going to put an X right here. Okay, side length of VT, we already said that these are similar. So I'm going to set this up as X from the bigger triangle corresponds with 5 from the smaller triangle. And therefore, now I have to come back to the bigger triangle. That's why this 2.5 is in the picture right here, okay? Because I need to take this entire side length. That's the only reason that 2.5 is there. And so the entire side length is 11.5 over the corresponding piece from the smaller triangle, which is 9. And now, once again, I can go through and do my cross multiplying. I get 9x. That has to be equal to 5 times 11.5, which is 57.5. Now I can go through, divide both sides by 9, and I end up with an answer for x of approximately 6.39 if you round correctly. Okay, 6.39. It turns out it's 6.388, which is why we rounded up. Then in this problem, they ask you to find the length of Tn, okay, which in this case we could call y. This one we can go through and we can solve for that. Let's say I'm going to do this one a little bit differently. Let's say I use the smaller triangle first and then the bigger triangle. So I'm going to use the 11 over the corresponding side from the bigger triangle, which would be the sum of these two pieces. So 11 would go over y plus 11. If you remember back to the last lesson, we talked about rewriting these. If you need to rewrite these triangles as two separate ones so you can see it easier, go ahead and do it, okay? Then we would come back and we would put 9 over 11.5 again, okay? So we have this side length, small side, over the corresponding big side, and then small side over corresponding big side. And now we can go through and we can solve this. So if we take a look, I would have 9 times the quantity, y plus 11, equal to 11 times 11.5, which is 126.5. And now we can solve. I'm going to distribute the 9. 9y plus 99 equals 126.5. Subtract the 99 over, which means 9y equals 27.5. And then we can divide both sides by 9, and I get y approximately equal to 3.06 if you round correctly to the hundredths place. That one turns out to be 3.055. Okay, so there's your first lesson. There's the 3-2-3 of using those. This was kind of just more of a practice lesson of using these ratios and determining, do I have similar triangles? Okay. The last question then is, well, what happens if you notice where, in this case, these two triangles are similar because they have a congruent angle. Here's a ratio of 1 to 1. There's another ratio. They're in the same ratio. So the question is, or the idea behind this last part here for this is, not only are these two triangles similar, they are also congruent because they have a zoom factor of 1. Anytime you have a zoom factor or a scale factor of 1, when something's in a 1-to-1 ratio, that means it's the same size. Okay? So if two triangles are similar with a 1-to-1 ratio, then those two triangles have to be congruent to each other. Okay, so just keep that in mind. That's the if-then conjecture they were talking about right down here. All right, so then that takes us to lesson 3.2.4. That was more of a practice lesson and just recognizing as well that congruence means similar plus a 1-to-1 ratio. Now we're going to look at, are there any other conditions for similarity? Okay, and so as we go through and we take a look, notice we had said, and I'm going to highlight a couple things here. Notice we had a side-angle-side similarity condition, and we had an angle-angle similarity condition. Those were the two that we already know of. The question is, if you come down here, is there such thing as a side-side similarity condition? Okay, would that work out just like the angle-angle one does? And so if we take a look at that, this Robel said he's got 4 and 5 centimeters as side lengths. Is it valid? And the idea is, if similar to like side angle side that we did in the last one, if you don't have that angle in between, now the side opposite that angle, okay, let me actually draw you a picture here so you can kind of see what I'm talking about. If this side length is, let's say that's a side length of 4 and that's a side length of 5, but we don't know what that is, I could go through and I could draw the 4. Okay, here's my third side length if I put it dotted. I could draw the 4 this way and the 5 that way. And now you can quickly tell that without knowing that angle in between, there is no way that these triangles are similar. They are not even the same shape. They do not have the same angle measures. So this one hopefully is a quick one that you can tell that is side-side similarity a valid condition, and the answer is definitely not. Okay, so now if you notice, Tashi asks, I want to test angle-side angle similarity, which means I start with 2 pairs of congruent angles and the length of the side connecting these angles being proportional. Would that be enough? Okay, and so the question is on the next problem here, if we just listed out some stuff, we already said we had angle-angle similarity. That one worked. I'm going to circle that. We already said we have side-angle-side similarity. That one worked. We just talked about side-side similarity. That one did not work. Okay, now we're looking at angle-side angle. Whoops. That's going to come up later in the lesson. Angle-side angle similarity. Or we could go through and we could have a bunch of different options. What if we had angle-side angle similarity? Okay, those types of pieces. What if we had side similarity? Does that work? 2 sides didn't, but would 3? Okay, and so on and so forth. So that's kind of the idea. What if we had side angle side similarity? Okay, and so what I want you to notice quickly is we can go through some of these right away because I can tell you that this one's going to work, and the reason it's going to work is because it's got 2 congruent angles in it. So it's really just another version of angle-angle similarity. I'm going to tell you that this one right below it is going to work for the exact same reason. Okay, I'm going to tell you that this one would work because of the fact that you have side angle side as part of it. So even though these ones that I just circled would work, it's only because of the fact that they are just some other version of angle-angle versus side-angle-side. So I would not necessarily want to have to do any of those extras. I don't need to do these because I've already got them included in my first 2. The question that we're going to take a look at today is, what about this one? Side, side, side. Would that work out? Okay, that's what we're going to take a look at. So if we go through and notice it says before experimenting, make a prediction. What do you think? So think about it in your head and see what you think. Will this actually work? Will this form similar triangles? So the first one triangle we're going to test out has 3, 5, and 7 as side lengths, and then you can notice 6, 10, and 14. So we're in a ratio of 2 here. Okay. So, but is that enough? Well, what I'm going to do on this problem, I've already brought it up here, and so here's your 3, 5, and 7. There's your 6, 10, and 14. I'm going to go through and connect the 3 to the 6, those 2 sides. Okay. I'm going to connect the 5 and put that ratio with the 10. And then I'm going to connect the 7 to the, that's supposed to be a 14. I don't know why it wasn't. But so if you notice, here's our ratios right over here. You can see that they're all in a 2-to-1 ratio. Okay. Well, now, as I go through and I start to move this around, notice the side lengths are changing, right? But what I want you to notice is the ratio. The ratio is staying the exact same, and therefore, we can even go through and I can show some stuff. Let's say I show the angle measures. What I want you to notice is now, right now, we've got 29, 139, and 12. Notice 29, 139, and 12. Okay, so in that case, those happen to be working, and it looks like the ratios are staying the exact same, no matter how we change things. Then let's say we come to this one. This is kind of part B of this problem. So the 3 is going to match up with the 6. The 4 is going to match up with the 8, and the 5 is going to match up with the 10. So again, we're in a 2-to-1 ratio, and the question is, let me show the angle measures. The question is, does that ratio, notice, stays in a 2-to-1 ratio? Take a look at the angles. 99, 42, and 39, those stay the same. 63, 56, and 61, those are the same. And no matter what we do, those are actually going to stay the exact same. Okay. While I'm here, I'm going to show you one other one. There's one last thing where, what if I take the 4 and we match it up with the 6? What if I take the 6, the second biggest side, match it up with the 9, the second biggest side, and 8, we match that up with the 12. And now, same thing. Let me go through and actually show the angle measures here. So if we take a look, notice we've got 1.5 as our ratio. It stays 1.5. And again, if you notice the angles, 33, 40, 107. I go to some other part, 74, 83, and 23. Well, if you take a look, there it is. Okay. So the conclusion I'm hoping you're coming to is that side, side, side is a valid, this one is going to work. I'm going to add that to my list here. That is going to work as a valid reason. Okay, and so what I did is I already took a look at all of this information. We just did all of this kind of stuff. So that means that this will work, and therefore we now have 3 different pieces of information to prove that 2 triangles are similar. Okay, and that is if 3 pairs of corresponding proportional side lengths, that is side, side, side. Okay, that can be used to determine triangles are similar. So that is your side, side, side similarity. Okay, so let's go through then and kind of finish this up. So if I was going to test another similarity condition here, the idea behind this is now we're looking at side, side angle, which I accidentally wrote the other direction before. So if we go through and we test that, where let's say that we knew, okay, something like this, we knew 2 side lengths were 4 and 5, and then the angle that was after it. What I want you to see, we're going to test it doing this. So here's my 5, okay? Let's say that this side length right here is the length that's 4. And I'm trying to figure out then how, and I put 40 or 50 degrees here instead of 49, but you get the same idea. So here's the length of 4. What I want you to take a look at is I'm going to take that length and I'm going to match it up, and then I'm going to use this compass to figure out what's going on here. And what I'm hoping you're noticing is if this side length is 4, there's actually a couple of different places we could have this being one of my triangles. That would be 4, 5, and then 50 degrees. Or we could end up with this being a length of 4 that I just drew in, 5 and 50 degrees. And those angles, if you notice, are definitely not similar to, those triangles are not the same shape. Okay? So in this case, this is not going to go through, and this will not work. Okay? So what that leaves us with is 3 sets of similarity shortcuts, which right here they started talking about, go through your lists. So here's our final list of similarity shortcuts. We've got 3 different ways. We have angle similarity, we have side angle side similarity, and we have side 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 similarity. Those are the only ways that we know that triangles, that we can prove that 2 triangles are similar to each other. It has to fall into one of these 3 categories. Okay? And so finally, practice to learn. What I want you to do is just, since we combined 2 lessons, I want you to do just the 3-2-3 practice to learn. You do not have to do the 3-2-4. You can skip that. And then in this, the problems I want you to do are 376 to 381. But you can skip problem 3-79. Okay? Good luck with everything, everybody. Hopefully this made some sense. I know it's a little bit longer lesson, but that's because we combined 2 into 1. So good luck. If you have any questions, bring those questions to class, and we will see you moving forward. Okay? Good luck.